So this is Miss Muse here, wanting to continue our conversation about scientific notation. So you'll remember yesterday we left off with a discussion about how science, it's not unusual in science for us to have to consider measurements that are very, very large and measurements that are very, very, very small. And the examples that I gave revolved around water. And we also had a discussion about how it would be incredibly inconvenient and incredibly error-prone to write numbers in this way on a consistent basis. So for that reason, in science, such quantities are written in scientific notation. So the basic ideas around scientific notation have to do with the fact that every time that we move a decimal place, we're changing the value of that number by a factor of 10. In other words, the difference between 100 and 1,000 is one decimal place, and that is a difference in a power of 10. So, for example, one decimal place difference equates to 1 power of 10. So in other words, really, 200 is really 2 times 10 squared, right? And so by doing that, all I've done right now is I've simply written this value in scientific notation. So there's a couple of things I want you to notice here. Notice that the value that I have, this 2, in this particular example, is a value that is less than 10 and greater than 1. So the value has to be between 1 and less than 10. And then I'm going to multiply that value by a power of 10. And the power of 10 is going to be such that if I multiplied this initial 2 by it, it would give me back the number that I originated with. Okay? So another way to think about this is this, and then we'll come together for a format on all of this. So really, my decimal place, even though we don't write it in, is at the end of this 200 right there. So in other words, I could write a 200.0, and that would have the same numerical value. To write it in scientific notation, I need to make sure that the first value that I have is a number between 1 and less than 10. And so in order to get there, I need to take this decimal place and move it back 2 spots to the position where it is a 2.00. Okay, so that's where this 2 comes from. And then I look at how many decimal places that I needed to move. In order to get that 2, I needed to move it 2 spaces. That tells me what the exponent is on my power of 10. So let's go over that format again. So I have this value here, and the number that goes in that position comes from looking at the long, really, really large number or long, really, really small number. And I need to move my decimal place so that the value that goes in that spot is between 1 and less than 10. And I'm going to multiply that by a power of 10, and the exponent that goes with that power of 10 is based on the number of decimal places that I needed to move in order to get a value over here that is between 1 and less than 10. So I'm going to say 1 all the way up to less than 10. All right, so let's begin by working through a few examples of numbers written in scientific notation. And so again, I'm going to assume that my decimal place is right here where all the zeros end. And I need to remember my basic format. So the basic format is, and I'm just going to draw this line just so we remember. And then I know I have a number here that is between 1 and less than 10 that comes from this really large number. I'm going to take that base value and multiply it by a power of 10 to some sort of exponent, right? And by multiplying it by a power of 10, that's basically going to tell me how many decimal places that I moved in order to create this number. So let's count back. So when I look over here, I know that I need to get a value in the first spot, my number written in scientific notation, that is between 1 and less than 10. So I'm going to move my decimal place. I'm going to skip all these zeros. And I don't want my decimal place here because then I end up with 167. And that does not follow the rule. I'm not quite done here because 16.7 is not less than 10. So I ultimately am going to have to put my decimal place right here. So that gives me the base for this power, written in scientific notation, of 1.67. Okay. Now remember, I'm just writing the same value in a different form, and so I know that this large number is not equal to 1.67. So I need to let the reader know how many times I need to multiply it by 10 in order to get back the original number written in standard inconvenient form. So let's do that. So I move my decimal place 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21 spots. And so my exponent here ends up being 21. So there I have it. So the number 1.67 times 10 to the 21. That is how I would convert that value into scientific notation. So now notice a couple of other things. Now I need to be reasonable. I need to make sense of my answer. And so if I look at this number, 1.67 times 10 to the power of 21, I know that my power of 10 here has to be positive. Because the only way I take a number like 1.67 and turn it back into its really, really large number is if the power of 10 is positive. And so that's one way I can reason as to how, what the sign on my power of 10 needs to be. Let's try a few more examples. I want you to practice and then see how I solve them to make sure that you're on the right track. Okay, so give this example a try on your own. Pause the video, give it a shot, and then check your answer to see if it's in line with mine. All right, so I'm going to take this up now. So when I think about where the decimal place is currently, it's over here at the end of where these zeros are. And so I know that I need to move it to a position where the value that results is between 1 and less than 10. So I'm going to move it all the way over, skipping these zeros, and I know that it needs to be right here between the 8 and the 3. That is where I'm going to, that's where I'm going to put my decimal so that I have this base value of 8.3. But of course, 8.3 is not equal to 83 blah 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 zeros, right? So I need to multiply by my power of 10 so that I let the reader know I'm not just talking about 8.3, I'm talking about a huge honking number. And so the value for my exponent on the power of 10 is based on the number of decimal places that I moved it. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, and then one more to get it between 8 and 3, so 25. So hopefully you got that right, and if not, please ask for help. Now, not very often will you be asked to convert from scientific notation back into standard form, but it will help your understanding of the reverse process. So let's go through this. Give it a shot on your own, see how you do, and then check to see my solution. All right, so I'm going to type this one out because I don't think that all my zeros will fit in here with my messy writing. So I know that I'm going to have to take the decimal place where it is right here and move it 18 spaces to the right. That means I'm going to need to backfill with a bunch of zeros. So I'm going to start. So the 9 was already there. That's where my decimal place is currently. So I'm going to move it 3 spaces by going 5, 8, 3. So far I've moved it 1, 2, 3. But I've got 18 spaces to move it in total. So I've used 3 of the 18. That means I need 15 zeros left. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And so don't worry so much about the spacing. I'm not really worried about it, but usually generally you go from the back end and then space them out as such in groups of 3. So hopefully you did that okay. One mistake that commonly occurs is that people forget to count in the 5, 8, 3, right, the decimal places, and so they end up with 18 zeros instead of the 18 minus the 3, accounting for these values here. So hopefully when you practice that on the worksheet, you'll manage to kind of remember not to make that mistake. So if you have numbers that are less than 1, then one thing that you need to remember is that your power of 10 will be negative. But the process is essentially the same. I'm going to want to take my decimal place and move it to a position where the value that results is between 1 and less than 10. So my decimal place is currently here, and I'm going to want to move it between this 2 and this 9 because that will give me 2.99 as my base for this scientific notation. So I'm going to write that out. Oopsies. 2.99. Really slow writing. There we go. 2.99. And I'm going to multiply that by a power of 10. And the power of 10 is based on how many decimal places that I needed to move in order to get that 2.99. So that is, whoosh, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. So I moved it 21 spaces. But now let's look at this value here that we get and make sense of it. Let's be reasonable. If I take 2.99 and multiply it by 10 to the power of 21, that's not going to give me back this really small number. It's going to create a humongous value. So that's where my reasoning skills, my skills of logic come in and tell me that the only way this works is if I remember that I really want to make this a negative exponent because that will move my decimal place in the opposite direction. So, with very small numbers essentially that are less than 1, your exponent on your power of 10 will be negative. So take a minute to work through these 2 examples on your own to ensure that you're understanding these ideas, these concepts properly. And if you're struggling, please be sure to ask me some questions to clarify. Also, when you're done this, I want you to take a look on Google Classroom. There you'll find a worksheet that will allow you to practice these skills. You'll find if you scroll down, then you'll also see the solutions for the worksheet as well so that you can keep track of how you're doing with these questions. All right. So let's solve this. So when I look at this question here, I have a very small number. So I'm going to move my decimal place in a position between the 5 and the 9 because that will give me 5.9. And I need that value to be less than 10. So 5.9 is what I have as my base for this number written in scientific notation. Now I'm going to multiply it by power of 10. That will get me back to that original really, really small number based on the number of decimal places. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I moved it back 10 spaces. So that means my final value written in scientific notation is 5.9 times 10 to the negative 10. All right, let's look at the next example. So I have 7 times 10 to the power of negative 13. So I need to remember that this first 0 before my decimal doesn't really count, okay? Because my starting point for moving the decimal is where it exists currently. So I have 0 point. Now I need to backfill with enough zeros so that I have moved my decimal place 13 times to the right. So 1, 2, 3. And some people think that you will need to add 13 zeros, but that's not the case because the 7 still needs to be in there. I'm going to type this out just for ease of showing you, because that would have been a lot of zeros and it would have taken us a lot of time. So 0.0. So there I have 1 0. I've moved it 1 decimal place already. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and then my 7. So one way to check to make sure that your answer is correct is to just try to take that number in standard form and convert it back to scientific notation. And if you've written it correctly in standard form, then you should end up with your original value. So let's just make sure. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and then 13. I'm good to go. All right, so now you hopefully are ready to begin your worksheet, which will again be found on Google Classroom.